Welcome back. In the last video we looked at these two examples here where we worked out these limits using first our constant property, taking a constant out of a limit, and then our addition and subtraction properties in the second example. I want to continue here. This time we have a limit as x approaches pi over 6 of 4x times sine x. And we want to work this out. Well, 4x times sine x, that's a multiplication. But we have a property that says that limits distribute across multiplication. And the 4, by the way, is a constant, so we can pull that out first off. And then for limit of x times sine x, we can do limit as x approaches pi over 6 of x, and times limit as x approaches pi over 6 of sine x. And then for x approaching pi over 6, that's just x, so we can just evaluate it. And pi over 6 is part of the domain of sine, so we can just evaluate that one as well. And so it turns out overall we can just evaluate this thing. So that's going to be 4 times pi over 6, and then sine of pi over 6 is 1/2. And then we just simplify the 4, and the 2 cancels to be a 2, the 2 and the 6 cancels to be a 3, and we get pi over 3. Limit as x approaches pi over 6 of 4x sine x turns out to be pi over 3. So in broad strokes later on, then we can just recognize that this is a situation where we can just evaluate the limit. This is a situation where we can just evaluate the limit. Continuing on here, we have limit as x approaches 3 of x squared plus 4 over x minus 5. So we have a limit of a fraction this time. Limit of a fraction this time. And so remember our rule for limits with fractions or division is we can do that as long as the limit of the bottom is not 0. So as long as the bottom is not going to 0, we could do the limit. And so we go ahead and distribute the limit through to the top and bottom. The top is just a polynomial, which we know we can just evaluate. So we can just plug into 3, and same thing the bottom. And the bottom does not come out to be negative, or does not come out to be 0, so we're all right there. In the top we'd have 3 squared plus 4. In the bottom we'd have 3 minus 5. Top becomes 13, bottom becomes negative 2. Put it all together, negative 13/2. Okay, so hopefully this will help you at least understand and appreciate a little of how these limits work. Again, please check through the notes as I kind of point out some real important things like a limit of a polynomial, how to do that, and limits of rational functions as well.